Here's problem 13:18. Two satellites are placed in geosynchronous orbits with periods of 24 hours, where each satellite hovers over a spot on the Earth's equator. Satellite B has 3 times the mass of satellite A. What is the relationship between the magnitudes of the gravitational forces of the Earth on the two satellites? Well, if these two satellites have the same period, by Kepler's third law, they all have the same radius of orbit. So in a sense, if we were to graph this, here's the Earth, and we have these satellites in orbit here, and here's satellite A and B, which is bigger, and they have the same radius of orbit. So here's some radius r and the same radius r to B. So we're just told that the mass of B is 3 times the mass of A. But they have the same radius because they have the same period of orbit. Sounds good. So based on that, if we were to look at the force of the Earth on A, that would be equal to G times the mass of the Earth times the mass of A over the distance between them squared. And as we look at this, G times the mass of Earth over r squared would be the gravitational acceleration at that radius. So this would be equal to the mass of A times the acceleration of gravity at that radius, whatever that is, in the form of Newton's second law. If we look at the force on satellite B, that's equal to G times the mass of Earth, mass of B, over the same radius, r squared. And again, we have G mass of Earth over the radius at that point. That is the acceleration of gravity at that point. So this would be equal to the mass of B times the acceleration of gravity at that point. So if we took the ratio of these two forces, force of B divided by the force of A, that would be equal to the mass of B times G prime over the mass of A times the same G prime. G primes cancel out, and so the ratio of these forces is the ratio of the masses. Now mass B is equal to 3 times the mass of A over the mass of A. So the mass of A cancels out, and the ratio of these forces then is equal to 3. In other words, the force on B is equal to 3 times the force on A, because B has 3 times the mass. Everything else being equal, the same acceleration, the same period of time, but it has 3 times the mass, so the gravitational force is 3 times as much. And our answer then is D.